think about this for a second. Almost 50% of adult women in the United States experience stress urinary incontinence.
Right, which is just a massive number. Half of the adult female population.
Literally half.
Yeah.
And yet, when attempting the baseline conservative treatment, which is, pelvic floor exercises, upwards of 30% of those patients are executing the movement completely wrong.
Yeah, they're completely missing the target muscle.
Exactly. So today we are diving deep into some fascinating clinical trials, Cochrane systematic reviews, and even MRI studies that look at this.
There's a great stack of research we've got today.
It really is. And our mission for this deep dive is to answer a highly specific, very practical question for you. Can weighted vaginal cones or, high-tech biofeedback sensors actually improve the resting tone of the pelvic floor to treat this?
The sheer scale of stress urinary incontinence, or SUI, really demands a hard look at how we approach rehabilitation.
Definitely.
I mean, we are talking about involuntary leakage during physical exertion. So a cough, a sneeze, laughing, or like lifting a heavy box.
Right.
Fundamentally, this is a mechanical failure. It is a lack of closure pressure in the urethra when intra-abdominal pressure spikes.
Okay, let's unpack this, because visualizing that mechanical failure helps a lot. The pelvic floor acts like a physiological hammock, right? It's made of muscle and connective tissue, and it supports the bladder, the uterus, and the rectum.
Yes, the levator antemuscle complex is basically the main support structure of that hammock.
And for that hammock to do its job, it needs a continuous baseline tension. Like, it can't just hang loose.
Exactly.
When it loses that natural tension, which is known as its resting tone, the physical support structures just sag, and then sudden a downward pressure just forces urine right through the urethra.
Right. So restoring that constant levator tone is the primary objective of any conservative therapy.
Rebuilding the hammock.
Rebuilding its functional integrity and increasing that baseline resting tone. That is what ultimately creates enough continuous closure pressure to stop the leaks. But the debate right now in the clinical world is over the most effective way to stimulate that muscle complex. Can high-tech biofeedback sensors outperform something as simple and, well, low-tech as weighted vaginal cones?
So let's look at the high-tech intervention first, because honestly, the idea of translating an invisible internal process into a visual or auditory signal on a screen is like a massive leap in motor learning.
It is. And it exists because it addresses a very real neurological disconnect. We mentioned earlier that 30% of women cannot properly contract their pelvic floor just by, being told to do so.
Which is wild to think about, just totally unable to isolate it.
Right, because without a clear brain-muscle connection, the central nervous system essentially panics. It just substitutes nearby muscle groups instead.
So they end up doing what, exactly?
Well, patients end up bearing down instead of lifting up. They clench their abdominal wall, or they squeeze their glutes, tighten their adductors, or simply hold their breath.
Which, bearing down, seems like the exact opposite of what you would want if you are trying to prevent prolapse or incontinence.
Oh, it actively exacerbates the problem. So biofeedback intervenes by acting as a highly precise, real-time guide. A surface electromyography probe, an SEMG or a pressure sensor, is placed transvaginally.
Okay.
And it isolates and measures the bioelectrical activity of the pelvic floor specifically.
So as you attempt a contraction, a screen shows a graph spiking, or you hear a tone getting louder.
Exactly. You get instant confirmation when the correct tissue fires and total silence when you accidentally fire your glutes.
See, the motor learning theory here is incredibly sound. By creating an external visual feedback loop, you accelerate the brain's ability to map the internal terrain.
You isolate the correct muscles much faster than you would through, blind trial and error.
But wait, if I have a high-tech screen literally showing me my internal muscles firing, shouldn't that automatically guarantee a better workout? Like, why wouldn't this be the ultimate cure? The logic seems airtight to me.
You would think so. Right. You isolate the muscle, you train it efficiently, you fix the resting tone. But what's fascinating here is that the clinical outcomes don't reflect that straightforward logic.
Wait, really?
Yeah. While individual trials sometimes show an initial bump in symptom improvement, large-scale Cochrane systematic reviews paint a vastly different picture.
Interesting.
When evaluated across high-quality trials over the long term, adding a biofeedback device makes little to no difference in incontinence-related quality of life.
Wow.
Or leakage frequency, or perceived cure rates when you compare it to just standard pelvic floor muscle training alone.
So the fancy screens and graphs aren't actually moving the needle for the majority of patients over the long haul.
Right. It serves as a fantastic initial educational tool to overcome that 30% failure rate we talked about.
Just to help them find the muscle in the first place.
Exactly. But once a patient actually finds the muscle, the biofeedback basically ceases to be a treatment multiplier. The visual stimulus doesn't inherently make the physical contraction stronger.
Oh, I see.
Yeah, it doesn't make the resting tone higher than unassisted targeted training would.
So the brain figures out the map, but the map itself doesn't build the muscle.
Beautifully said.
Well, if high-tech sensors fail to create long-term structural changes beyond standard exercises, how do we mechanically force the muscle to adapt? I guess we strip away the screens and rely purely on physics.
Enter weighted vaginal cones. These strip the entire process down to gravity and reflex.
Which is so much simpler. And these were developed by Plevnik back in 1985, right?
Yes, exactly. You have a head of cones, typically silicone or plastic, ranging from 20 up to 100 grams. And the protocol is remarkably simple.
You just put them in?
Pretty much. The cone is positioned above the levator plate, and the patient simply stands up.
Okay, this is where it reminds me of progressive overload at the gym, but with a weird twist. Like, if you're doing a bicep curl, you are consciously commanding the muscle to contract and lift the weight.
Right, it's a voluntary action.
But with the vaginal cone, gravity is actively trying to pull the weight downward, and as it begins to slip out, it triggers a stretch reflex in the muscle spindles.
Exactly. The body senses the downward movement and involuntarily fires the pelvic floor muscles to hold the cone in place.
It's automatic.
Completely. The central nervous system bypasses the need for conscious, voluntary squeezing. It utilizes gravity as a constant low-level stressor that forces a reflexive contraction.
See, that reflexive aspect feels crucial for training resting tone. Because if the goal is a hammock with continuous tension, a subconscious reflex mimics that baseline state way better than me consciously doing Kegels for 10 minutes a day.
Absolutely. And in clinical practice, this breaks down into two distinct training phases. You have passive and active holding.
Okay, break that down for me. What is the passive cone?
The passive cone is the heaviest weight a patient can retain for 1 full minute while standing without engaging in any voluntary contraction.
So the body is just holding it there automatically, fighting gravity on its own.
Exactly. That passive retention is what directly conditions the resting tone over time. It forces the levator ani to establish a higher baseline of continuous tension.
And once that baseline is established,
Then you introduce the active cone. This is a heavier weight that requires conscious, voluntary contraction to prevent it from slipping.
oh, and I read that some of the modern cone designs also incorporate these little internal steel spheres.
Yes, those are brilliant. The internal sphere creates weak, subtle vibrations as the patient moves around, doing chores or walking.
But how does vibration actually enhance the muscle response? Like, what does that do?
It exploits proprioception. The vibration heightens the sensory feedback loop to the brain. The mechanoreceptors in the vaginal wall detect that kinetic energy, and it synergizes with the gravitational pull.
Oh, wow.
Yeah, this dual stimulus creates a significantly stronger reflex closure of the perineal muscles. It neurologically wakes the entire region up.
And the clinical efficacy backs this up, right? Because the Cochrane reviews confirm that training with weighted vaginal cones performs definitively better than no active treatment.
Oh, undeniably. And the data shows they are just as effective as supervised pelvic floor muscle training and transvaginal electrical stimulation.
Plus, the barrier to entry is radically lower. It's so much lower. They are inexpensive, entirely autonomous for at-home use, and they completely circumvent the need for expensive clinical biofeedback equipment while delivering comparable results.
Okay, so we have screens attempting to teach the brain on one side and gravity hacking the body's reflexes on the other. But we really need to look at what is physically happening to the muscle architecture under these protocols.
Right, the cellular level.
Yeah, like are we just making the muscles quote-unquote stronger, or is something deeper going on?
We actually have a great study on this. We can look
Okay.
at a 3-week intensive training study by Dirac and colleagues. They used static MRI to observe those exact morphological changes.
Oh, I love an MRI study. You get to see the actual tissue changes.
It's the best way to know for sure. So researchers put 24 healthy women through a rigorous program, splitting them into an instrumented group, which used biofeedback and electrical stimulation, and a non-instrumented group.
Okay, so what did the non-instrumented group do instead of using the tech? They utilized targeted voluntary contractions combined with hypopressive breathing exercises.
Okay, let's break down hypopressive breathing real quick because that sounds intense.
Yeah.
How does creating a vacuum in the abdomen actually train the pelvic floor?
It's a really interesting technique. Hypopressive techniques involve fully exhaling and then expanding the rib cage without inhaling. This essentially creates negative pressure or a vacuum in the abdominal cavity.
Right.
This negative pressure mechanically draws the diaphragm upward, and consequently, it pulls the pelvic organs and the pelvic floor upward along with it.
Oh, so it's a way to recruit and lift the levator ani without increasing intra-abdominal pressure.
Exactly, which is absolutely vital for patients dealing with stress urinary incontinence.
Okay, so you have one group using high-tech sensors and another using this targeted breathing and voluntary contractions. When they looked at the MRI after 3 weeks, what exact part of the hammock actually changed?
The imaging zeroed in on two key muscles of the levator ani complex, the iliocussages and the puborectalis.
Oh.
But the physical changes were highly counterintuitive. The MRI revealed that the intensive training actually decreased the overall volume of the iliocussages muscle.
Here's where it gets really interesting. Wait, the volume decreased, but usually resistance training induces hypertrophy, right? Like you would expect the muscle to get thicker and denser to support the urethra. Why is it shrinking?
It's because of what the muscle was losing. The MRI also highlighted a significant reduction in adipose content fat tissue within the puborectalis muscle at rest.
Oh, wow. So the muscle is losing that marbling of fat inside the muscle fiber.
Precisely. It's getting leaner and more efficient, rather than just bulkier.
That makes so much sense.
Right. By clearing out that fatty infiltration, you are left with highly functional contractile tissue. And here is the kicker. Both the high-tech group and the low-tech, non-instrumented group exhibited these identical physical changes.
Identical change?
Identical. Furthermore, both groups demonstrated significant improvements on the modified Oxford grading system.
Just to remind everyone, the Oxford scale is the one that measures manual muscle strength from 0 to 5, right? Where 0 is no contraction and 5 is a strong contraction against resistance.
Exactly. Both groups moved up the scale similarly. So the synthesized data points to a very clear conclusion. The low-tech route changes the muscle architecture just as effectively as the expensive biofeedback and electrical stimulation protocols.
That fundamentally shifts how we should approach treatment. Like, you don't necessarily need a high-tech clinic to completely alter the cellular makeup of your pelvic floor.
You really don't.
But before we declare gravity and basic exercises the definitive winners, we have to address the structural reality of moderate to severe stress urinary incontinence.
Yes. If we connect this to the bigger picture, we have to acknowledge a major physiological assumption these treatments make.
Which is?
That there is healthy, responsive contractile muscle tissue available to train in the first place. Continent women and those with mild SUI possess much higher maximum voluntary contraction strength.
Because their muscles are fundamentally intact, just maybe detrained.
Right. But when you move into moderate or severe SUI, the actual landscape of the tissue looks vastly different.
How so?
Biopsies and scans of moderate to severe patients reveal widespread muscle fibrosis. This is where healthy, flexible muscle fibers are progressively replaced by stiff, non-contractile connective tissue and scar tissue.
So if we think of a rubber band that has been left out in the hot sun, it dries out, it gets brittle. When you try to pull it, it doesn't stretch and snap back. It just pulls rigidly and eventually snaps.
That's a great analogy. It loses all of its elastic recoil.
Right. So if your pelvic floor has fibrosed, it literally can't stretch and contract to absorb abdominal pressure anymore.
Exactly. And that fibrosis is often accompanied by severe muscle fiber atrophy and a drastic reduction in type 2 muscle fibers.
Type 2 fibers being the fast-twitch fibers, right? The ones that need to fire instantly when you cough or sneeze to clamp the urethra shut.
Right. So if those fast-twitch fibers are physically absent, or if the muscle is predominantly fibrotic scar tissue, conservative training hits a physiological wall. You cannot progressively overload scar tissue.
Right. You can't train a muscle that isn't there.
Exactly. Reestablishing a strong maximum voluntary contraction becomes highly difficult, if not impossible, for patients with this level of structural deficit.
So if the muscle is actually atrophied or fibrotic, are we just asking a broken hammock to hold a bowling ball? Like, can cones or biofeedback even fix that?
The short answer is, for severe cases, neither biofeedback nor vaginal cones are going to fully restore the resting tone, because the tissue capable of holding that tone is physically gone.
That is sobering.
Patients might experience some mild symptomatic relief, sure, but the long-term durability of conservative treatments for severe structural deficits remains highly uncertain.
Which is where surgical interventions like mid-urethral slings, I assume, transition from being a last resort to a necessary mechanical fix.
Precisely. It really highlights the critical window for intervention. Catching this detraining in the mild stage before fibrosis sets in changes the entire trajectory of the condition.
So, what does this all mean for you listening right now? Whether you use a biofeedback screen to map the brain-muscle connection or a weighted vaginal cone that leverages gravity to trigger an automatic spinal reflex, the physiological finish line is identical.
Right, it's the exact same goal.
The goal is waking up the levator ani, reducing the fatty infiltration in the puborectalis, and restoring that continuous resting tone to support the pelvic organs. The data is clear that both approaches are highly superior to doing nothing, even if neither is a magic bullet for severe tissue damage.
Yeah, and finding the modality that ensures consistent compliance is the real takeaway here, because consistent progressive overload is what ultimately remodels the tissue.
There is one final thought that emerges from all this, though. We have two tools attacking the same mechanical failure from opposite sides. Cones rely on a deep, subconscious spinal reflex to stop a weight from dropping. Biofeedback relies on highly conscious visual motor learning.
Right.
So if treating SUI fundamentally requires retraining this brain-muscle connection,
Yeah.
it begs a much larger question.
Which is a fascinating thing to mull over. How much of female pelvic floor dysfunction is a purely muscular deficit, and how much of it is a neurological disconnect born from a modern, sedentary lifestyle?
A lifestyle that simply never requires us to automatically reflexively engage our core and pelvic floor the way human mechanics originally intended.
It's definitely something to think about.
It really is. Thank you for joining us on this deep dive. Keep asking questions, keep exploring the incredible mechanics of your own body, and we will see you next time.